All of you read this question. They are saying that a bullet of mass, how much, guys? What is a bullet of mass? 10 grams. Okay. Moving with a velocity of 400 meter per second, gets embedded in a freely suspended wooden block of mass 900 grams. What is the velocity acquired by the block, they are asking. So now observe very carefully. What do you mean by embedded? Anybody can tell? What do you mean by embedded? If you see the picture also, you can understand. What do you mean by embedded, guys? Anybody? Stuck. Do you understand it? So that is the meaning of embedded. For example, they are saying that, imagine this is what the bullet. Bullet is moving like this with a what velocity, Amma? Everyone, what is the velocity? Velocity is equals to 400 meter per second. Are you understand? Now it is strike to the wooden block which is suspended freely. Now after striking, it is stuck inside. That is what embedded we can say. Embedded means it is stuck inside. This is what the meaning of embedded. Are you understanding? Now what is the mass of the wooden block? Anybody? Open your mouth, then I can understand either you are understanding or not. What is the mass of the block? They have given
900 grams.
900 grams. So let me take, this is what mass of wooden block which is equals to 900 grams. Now, what is the mass of the bullet? Mass of the bullet is equals to 10 grams. Okay. Now you tell me, initially before the bullet is reaching the wooden block, what is the wooden block velocity? Is it 0 or it is having some velocity? It is suspended freely. What do you mean by that? Its velocity is what? Its velocity is 0. It does not have any velocity before hitting the bullet. Now, once the bullet will hit by it, now bullet is stuck inside this wooden block. Now, because of the fastness of the bullet, now once the bullet will stuck inside, is it the wooden block will move or not? Yes, please respond.
Yes, sir.
Yes?
Yes,
Now, where the bullet is stuck, anybody can tell? Bullet is stuck where? It is come out from the wooden block or it is stuck inside the wooden block? It is stuck inside the wooden block or it's come out? It is embedded, gets embedded. What do you mean by embedded? Embedded means stuck inside. So now if it is stuck inside means, then both are together only. Is it yes or no? Is it yes or no? Then what is the mass of that one? If you take, after once the bullet is embedded, then this one, the mass of this wooden block will increases both mass of the wooden block plus mass of the bullet. Is it right or wrong? Everybody? They're together correct now. All of you respond. They're together. Now together they are moving after striking. That is why we have to find common velocity, or we can say it is the velocity acquired by the block they are asking. So we can say common velocity. What we used to call? Common velocity. Understand everybody? So let me consider law of conservation of momentum. Once again, I will try to come the first. I try to understand what is the law of conservation of momentum formula. Anybody? M1 U1 plus M2 U2, which is equals to, try to answer, M1 V1 plus M2. Is it understanding? Now, let me consider mass of the bullet is 10 gram and the initial velocity of the bullet is how much, guys? Initial velocity is how much? 400 meter per second. Now, mass of the wooden block is 900 grams. And what is the initial velocity? It is just freely suspended. Freely suspended means what is the velocity? Freely suspended means velocity is equals to what, guys? Hey, open your mouth, yaar. If not interested, leave it, no issues. Velocity is 0. So that is what you have to understand. Now, once the bullet is stuck inside the wooden block, then their mass both will be together added. M1 plus M2 is equals to M. Same way, after bullet is stuck inside, both the velocity is also added. That is what? V1 plus V2, which is equals to what? V1 plus V2, which is equals to what? V. That V only we used to call it as common velocity. What is to call?
Common velocity.
That is what. Once the bullet is stuck inside this wooden block, then it will both will go together. That is what we can say common velocity. Now, observe very carefully. Speed is in meter per second, weight is in grams. Is it both are same units? This is CGS unit and this is SI unit. Is it possible to substitute both in together?
No, sir.
No. So then we have to convert into what? Mass we have to convert into what?
Meter per
We have to convert into what, guys?
kilogram.
Kilograms. Now anybody can tell 0.1 grams means how we can convert? So M1. So M1 is equals to 10 grams means I can convert 10 into 1 by 1000 kilogram. Okay. Same way. Next M2 is equals to 900 grams, which is equals to 900 into. You have to speak, I should not. That is what. So 0 will get cancelled, which is equals to 0.01 kilogram. Same way 00 will get cancelled, which is equals to 9 by 10 kilogram, which is equals to what? 0.9 kilogram. Is it yes or no? Yes, please.
Yes,
Everyone? Now substitute the values. M1 is equals to, what is M1 equals to, everybody? M1 is equals to M1 is equals to
0.01 kg.
kilogram. Units also you can remove. No need of units. Just values you can substitute it. We want to find the velocity. Velocity acquired by the body. So velocity alone. Into initial velocity. What is that? 400 plus M2 is equals to 0.9 into U2 is equals to how much, guys? U2. It is in state of rest. Freely suspended. So in state of rest before embedding. So what is the initial velocity? Mitaksri?
0.
Ready, call to Danishkar. And one more fellow is missing. Kaushik. What he thinks he is sleeping. Next. This both we have been considered as M into V. Now what is the combined mass? Check it. Once the bullet is embedded, combined mass is equals to, what is that? Combined mass is equals to 10 grams plus 900 grams, which is equals to how much, Hari? 910 grams, which is equals to 910 into 1 by 1000. 1 by 1000 kilogram, which is equals to what? 0 will get cancelled. 91 by 100, which is equals to 0.91 kilogram. Is it right or wrong, everyone? Yes, please. All of you.
Sir.
That is what. Now you can substitute it. That is what the common mass. What is the common mass, everyone? What is the common mass? Let it be, we can make. So 0.01 into 400. How much it is, everyone? 0.01 into 400, which is equals to how much? Which is equals to 4. Everybody. Very good. Which is equals to what? 4. Next. Anything into 0? Anything into 0? 0 only.
0.
Mass is equals to 0.91 into common velocity. Now we want to find velocity. This 0.91 is in multiplication. Will come this side. What will become? It will become it will become what? Division. So 4 divided by 0.91, which is equals to velocity. So everybody do this division and tell me the answer. Velocity is equals to 4 divided by 0.91. What is the answer? What is the answer, everybody? Solve it and tell me. You'll get it 4.395. Like this you'll get it. What is the units of velocity? Gokul, Kaushik, not even opening mouth. Again, why silent? Arun Kailash, what is the velocity unit? What is the velocity unit?
Meter per second.
Meter per second.
Meter per second, sir.
Now you are answering after everybody saying meter per second. That is what. So now you can rounding off to. So as we know, second digit is greater than 5 or equals to 5. We can borrow one thing to previous digit and we can wind up. So which is equals to, what is the answer? 4.4 meter per second. So once the bullet is stuck inside the wood, so both will go with the what velocity, guys? What velocity? 4.4 meter per second. Now check it. What is a book back answer? Book answer. So you can mention it. Common velocity is equals to, therefore the common velocity, or we can say the velocity acquired by the block after embedded, which is equals to 4.4 meter per second. That is what the answer you have to write it. Okay. So now try to solve it. Have you understand, Mitakshri, this question?
Yes, sir.
Yeah. So once if anybody is stuck, anything is stuck inside our body, we have to add the mass of both the bodies, and later they cannot go separately. They have to go together. That is what we can say common velocity. What we used to call, ready? Yesterday also I told you correct velocity.
Yes, sir.
This is what it is happening. So try to solve everybody, but all the units must be similar. So that is why unit conversion is mandatory. Everybody should convert always mass. If they have given whatever they have given, mass must be taken in what? It must be taken in kilograms. If velocity is meter per second, that is what you have to remember it. Everybody. So solve it, please. Ready? Have you called to Tanishka?
Yes, sir, you did not answer.
Okay, leave it. Now solve it. First convert the mass neatly, later only how to do it. Okay. So this is what is when the some body is stuck together, you have to use this formula and you have to solve like this. Okay. So all of you do it. Is it clear?
Yes, sir.
Solve that. Very, very important sum. So like this, now your exercise, you are having common velocity sums. Now can you able to solve that common velocity sums? You can easily will solve now, whatever it is.
Yes,
Okay.
sir.
So whatever the body, I will explain you some cases also. Observe now, complete this sum. Once it is completed, let me know. Later I will explain you the cases.
Completed, sir.
Yeah, okay. Let them others also. Mr. Arun Kailash, have you solved? Akilan,
Yes, sir.
Sir,
yeah, have you solved? Okay.
sir, going to solve, sir.
Yeah, solve. Gokul Yura, Mr. Danishkar, why are you?
Solving, sir.
Yeah, Danishkar, you also try to solve. Once it is completed, let me know. I will try. Next one. Now, some tricks I will say to solve the numericals, as already few people knows, but still all should know. So that is why. So everybody, once if you solve this question, then we'll move further, and I will say that. Is it completed, Mitakshri?
Yes, sir.
Yeah. What about this Kaushigra? Okay. So let's start now. Arun Kailash completed?
Yes, sir.
Okay. Saying yes not, if not completed, then we'll see. You have to solve now all the sums, if you have been understand. Now let us see. Observe very carefully. As we know, law of conservation of momentum. What is law of conservation of momentum formula? Everyone? Law of conservation of momentum. What is the formula?
M1, U1,
Everyone, M1 U1 plus M2
M2, U2, plus M1,
M2,
V1,
U2 is equal
M2
to
2, V2.
Understand? So this is the formula. You can see all we have been considered positive. Is there any negative one? Is there any negative sign? No. Now, when
Yes.
we use this formula, keep it in mind, for every case we can use the same formula, but all the initial velocities and final velocities are positive. Keep it in mind. All the velocities, of course, mass will never be negative, but velocities will be negative. We have to consider when the bodies are moving in opposite direction. Okay, so all the velocities are positive when, remember, before collision and after collision bodies are moving in the same direction. After collision bodies are moving what? Moving in a same direction, then we can say all the velocities are what? Positive or negative? All the velocities are positive. Keep it in mind always.
Positive.
So with the diagrammatically will explain. For example, let me imagine this is what the one car. Now car is moving in the forward direction. So like this, what is the velocity? Velocity is equals to positive. Initial velocity is what? Positive only. Do you understand everybody? Now another car is also moving in the same direction. Then this initial velocity is also what? Initial velocity is also what we'll consider?
Positive.
Positive only. Do you understand, Mitakshri? Now they collide. This is what? Before collision. What is this? Before collision. Understand? Now after collision, again they are moving with the same direction. Again same direction. So what is the initial velocity? Positive or negative? Positive only. Understanding? Now after collision, this car is also moving in the same direction. Then its final velocity is also what? Final velocity is also what? Positive only.
Positive.
We consider this case only and we derived the formula. That is what law of conservation of momentum. Is it yes or no, everyone? We assumed this case only. Before collision and after collision, bodies are traveling in the same direction. So that is why we are getting this formula. Is it right or wrong, everybody? Yes, please.
Sir.
Now, observe. Suppose if bodies are traveling in opposite direction, observe very carefully. Now, this car is coming like this. This car is coming like this. Let me consider its initial velocity is positive or negative? Positive or negative?
Positive.
Positive. This is the body one. Now, opposite another car is coming. Opposite another car is coming like this direction. Now you tell me its velocity is you have to consider negative or positive before collision.
Negative. Sir.
Before collision, all of you should remember it is opposite. So U2 will become what, Mitakshri? U2 will become negative. Is it okay, Ma? Are you clear? Danishkar? Arun Kailash? That is what. Now, before collision, what is happening? Now, after collision, check it. After collision, again they are moving in opposite direction. After collision, again they are moving in opposite direction. Now you tell me, means after collision, this body will go like this body will go like this. Now tell me which is positive, which is negative. After collision, they will go in reverse direction, reverse, or we can say opposite direction. Now anybody tell me what is the sign convention? Final velocities. Anybody? Yes, please.
M1 will become minus.
Minus. Sir.
M1 not. V1 will become minus. Velocity is only ready. Mass will never be zero. Mass will never be negative. So now, after collision, this body is moving in this direction. Now, after collision, this body is moving in this direction. Now, you tell me, what about this one? V1 is what?
Negative, sir.
One is negative. Now this body is moving like this direction. So V2 is what?
Positive.
V2 is positive. Do you remember all of you? Everyone,
Yes, sir.
this is before collision. This is after collision. Is it okay, everybody? Yes, please respond. Yes.
Yes, sir.
Now, next case. Observe very carefully. Till now, both everybody note it down. Any doubt, ask me. Clear? Yes, Mitakshri? Danishkar, have you
Sir.
understood sign convention? Okay. Now, observe very carefully. Next one. Next case is first bodies are coming in opposite direction. Bodies are coming in what direction? Bodies are coming in what direction? Initial velocity is positive before collision. Before collision. Okay. Now, this body is coming like this direction. Now, this velocity we have to consider what? Initial velocity negative. Okay, everybody? Yes, please. Hurry, ready. Now, after collision, for example, imagine these bodies are moving both in the same direction. Now, for example, this body is bigger in size, so it has been dominated this one. So both after collision, both are moving in the same direction. Now you tell me, what about the final velocities? Anybody? So now
Minus.
after collision, this body is also moving like this, and this body is also moving like this only. Now you tell me, what is the final velocity? This body. Yes, please.
Minus.
Both are minus. Yes,
Okay,
sir.
small body.
Yes, Hari. Tell me. Final velocity of
Yes, sir,
this
it is
car is minus. Understand? Same direction, correct? Same direction. Then this car is also what? Both are moving in the same direction. Then final velocity of this car is also what? Is
Minus.
also minus only. That is what you have to remember. For example, they will move like this direction. Then what will happen? Both final velocity will become what? Positive.
Yes.
Final velocity of this one also will become positive. Is it yes or no? They'll move forward. Okay? They'll move forward. If they all will move backward together, then both velocities are negative. Are you clear, Hari? Any doubt, Hari? Understand, Ra?
So why is that is negative?
See, Hari, because this body is moving what? In this direction, correct, Hari? Opposite direction. Yes or no? So, this body is also moving in the same direction. So, if this body is also moving in the same direction, so opposite to this one is negative only, correct? So, V1 will become negative. Anyhow, this body is moving in the same direction. So, it will be always negative. So, this body is taking opposite direction. So, we have to consider negative. Understand, Hari?
Yes, sir.
Yeah. So that is what you have to remember. Now, next one. If you want to solve the numericals, like as we studied now, bullet is fired. What is that? Bullet is fired. Are you understanding? Now, bullet is coming with some velocity. So what is this initial velocity? Initial velocity is something we'll be taking. Okay. Now, its mass is also something they will give you. Now, if a wooden block is present here, or some body is present here, so the body is initially at rest. Initially at what, guys? Initially at rest means its mass is m2, but velocity is what? u2 is what? 0 meter per second. So all of you should remember, before hitting this momentum will become what? Momentum will become 0 meter per second. All of you should remember this. Are you clear, everybody? So bullet is before hitting or before embedding. Before embedded. Understanding? The momentum of wooden block is what, guys? The momentum of wooden block is 0 because it is in rest. Now, once the wooden block, the bullet is embedded inside the wooden block, then you have to add common mass. Then both will travel together. So that after hitting, what will happen? Common velocity you have to take. V1 plus V2 is equals to V. M1 plus M2 is equals to M. Is it okay, Mitakshri? Have you understand? Bullet questions. Once it is stuck or embedded, please remember, stuck or embedded, we can say, we have to consider after stucking or embedding, they will go with a common velocity. That is what we have to make it. V1 plus V2 is equals to V. We used to call it as common velocity. Please, all of you note it down. Is it okay, Ma? Nobody is answering. Yes, please, ready?
Yes, sir.
Yeah. Next. Observe very carefully. Next, for example, a girl is running with some velocity. Girl is running with what? Some velocity. What is the initial velocity having or not? U1. Now it is having her mass is also something. Now, here one trolley is present. One trolley is present. Observe very carefully. Now the trolley is moving. The trolley is in state of rest. Trolley is in state of what? Rest.
Rest.
What is the initial velocity?
Zero.
Trolley is state of rest. Initial velocity is what? 0. So mass is having something. Mass is having something. Now the girl is running and she jump into this trolley. Jump into this trolley. Now you tell me, before jumping, what is the momentum? Before jumping, what is the momentum? Only girl is having momentum. What is the momentum of the trolley? What is the momentum of the trolley? 0. That is what? So before jumping, M1 U1 plus M2 U2. So this full term is 0. Why it is 0? Because trolley is in what? Trolley is what? In the state of rest. Okay. Now which is equals to, after jumping, girl is inside the trolley or outside the trolley? Once she will jump into the trolley,
Inside the trolley.
he will stand inside the trolley. Now you tell me, is it they will go with the common velocity or separately again?
Common.
Common velocity.
Velocity. So both masses you have to add. Both mass of girl plus mass of trolley, which is equals to common mass. Next, velocity of girl plus velocity of trolley, which is equals to common velocity. So after jumping, what will happen? After jumping, so it will turns into what? Common mass into common velocity. Will you find it or not? Everybody? Yes, please.
Yes,
So in these cases, momentum of girl is equals to mass of trolley plus girl into velocity of trolley plus girl. That is what the formula. When? Before jumping, after jumping. So please all of you note it down. Very, very important one.
No, sir.
That is what. So you have to be very careful. When the questions are asking from law of conservation of momentum, so we have to be like very particular. What is the sign conventions? Which body is in state of rest? Which body is in state of moving? Everything you have to be very, very careful. Now, for example, we'll solve one question. Page number 77. Question number 60. All of you can read. Page number 77. Question number 60. It will be related to this one of the formulas only. So now you can see that all of you, this is what the question number 60 in our textbook. So now all of you read that. What is this? See that? What is the question? Try to read. A man wearing a bulletproof vest stands still on roller skates. Now the total mass is 80 kg. Now a bullet of mass 20 grams is fired at 400 meter per second. Now it is stopped by the vest and falls to the ground. What is the velocity of the man, they are asking? So can anybody tell me how to solve this question? Everybody. A man wearing a bulletproof vest. Let me see. First, given data, tell me. Who you have to try to answer.
Total mass.
Yes, please. Very simple question it is. They are saying that, you can notice it here. First, mass of the man, M1, tell me. He is standing on the roller skates. Let it be no issues. What is the mass of the man?
80 kg.
80 kg. That is what? Can I consider it? Yes or no?
Yes, sir.
That is what? Now here, there is no mass, there is no bullet and there is nothing. Very simple they have given. Now you can notice it. Mass of the man. Mass of the man. What is that, Hari? Mass of the man. Let me consider.
80
M1 is equals to what? 80 kilogram. Next. Now let me consider speed of the man after collision. That is what they are asking. Yes or no? Once the bullet is fired, understanding, bullet is stopped by the vest. Vest means like a bulletproof jacket and falls to the ground. Now they are asking, what is the velocity of the man? They are asking. Is it yes or no, guys? Yes, please. Please respond. Now let me consider velocity of the man is equals to velocity of the man is equals to V1, which is equals to, we want to find it. That is what we have to find. Yes or no, guys? Next, Mass of the bullet. Anybody tell me what is the mass of the bullet?
0.02.
Mass of the bullet will consider what? M2, which is equals to 20 grams, which is equals to what? 20 into 1 by 1000. Mass of the bullet M2 is equals to 20 grams, which is equals to 20 into 1 by 1000, which is equals to how much, everyone? Kilogram, we have to convert it, which is equals to what? 0.02 kilogram. Next, what is the speed of the bullet? Check it, everybody, or velocity of the bullet. They have given. Speed of the bullet
400 meter per
equals to how much? 400 meter per second. Now, again, observe very carefully and tell me, here bullet and man they are asking, like a gun and the bullet. What is the formula? Law of conservation of momentum. Momentum of the man is equals to momentum of the gun. Is it right or wrong? Is it right or wrong? Everybody, that is what.
Sir.
According to the law of conservation of momentum, law of conservation of momentum of man, which is equals to what? Momentum of bullet. That's all. So momentum of man, what is the formula, everyone? M1 V1, which is equals to momentum of bullet M2 V2. That is what. Now M1 is equals to what? We all people know. What is the M1? 80. V1 we don't know, which is equals to M2 is equals to 0.02 into V2 is equals to what, Hari? 400. Okay. Now we want V1. So now 80 is in multiplication will come this side. It will become what? Division. Okay. So now 0.02 into 400 divided by 80. Solve this one and tell me how much it is answered. So velocity of the man is equals to how much?
0.0125, sir.
0. Just normally
Sir, 1
turns into, yeah, how much it is?
1 by 10.
1 by 10. 1 by 10 means 0.1. Ready is wrong. Be careful. So 0.02 into 400, which is equals to what? 8. Yes or no? 8
Yes, sir.
divided by 80. So 8 ones are 8 tens are, which is equals to 1 by 10. 1 by 10 means what? 0.
0.
meter per second. So this is what is that? Velocity of the man. Understand? So I have to say the velocity of the man or the speed of the man, which is equals to 0.1 meter per second. Is it a tough question or easy question? Is it difficult, Sam? Akilan, Danishkar? Solve it. Everybody try to solve this question. Very important and very like these questions only they'll ask in exam also. All must solve. Have you understand or not, Arun Kailash?
Yes, sir.
Solve. Answer is completed. Tell me, I'll say.